Okay, so this is the 6-mark levelled question. This is basically about rates. So as with all levelled questions, let's go through and let's analyse what's actually being asked. So it says the reaction is first order with respect to iodine. Show that this statement is true. So one thing we need to talk about is how we know it's first order. It also says determine the initial rate and the rate constant. So there's 3 bits here, isn't there? So these would be our little 3 subtitles. So in terms of it being first order, what we're going to want to do is look at the half-life. If it is first order, then the half-life will be constant. So half-life is the time taken for the concentration to half. So we're going to go from 0.02 to 0.01. Now we should use a ruler. I'm not, but we should do. And so that first half-life there is 2,500. So from 0 to 2,500 is 2,500. Our next half-life is to half this again. So 0.01 to 0.005. Again, you should use a ruler. So that goes from 2,500 to 5,000. That is also 2,500. So my first half-life is 2,500. My second half-life is 2,500. My half-lives are constant. Therefore, first order. If it was second order, your half-lives would increase. If it was 0 order, your half-lives would decrease. For the next bit of the question, we're going to calculate the initial rate. So the rate of reaction on a concentration time graph is the gradient, the steepness, and as it's asking for the initial rate, we're going to need to find the gradient at time equals 0. So I'll try this as best as I can. I am going to use a ruler now to draw a tangent at time equals 0. They will allow a little bit of human error with this, but only a little bit. Kind of what it is, probably not the best tangent in the world. And then we're going to do our difference in y over our difference in x. So our difference in y is from 0 to 0.02. Doing a little quick bit of mental maths, I'd say that's 0.02. Check the axes, because often there's times 10 to this. In this one there isn't, but do check that because often there is. And our difference in x is from 0 to, it looks like exactly 4,000. So you'd bang that in the calculator, whatever that came out as would be your initial rate. They will allow a little bit of leeway. In the exam, in this mark scheme, they allowed from 4.5 to 6.5 times 10 to the minus 6. That was the range they allowed. So you could have a crack at it yourself, see if you're drawing your tangent accurate enough. Finally, it asks us for the rate constant. Now, there's a couple of ways of getting the rate constant. Probably the easiest way is just to say the rate constant K is equal to the natural log of 2 over your half-life. So using my half-life, you might have got a slightly different one, but it should have been about 2,500. Is the natural log of 2 over 2,500, and that will come out as your answer. So again, they gave you a little bit of a range on here. The range they allowed in this one was 2.25 to 3.25 times 10 to the minus 4.